Hello, and welcome to this session of problem solving session. And I'm going to actually work two homework problems, homework assignment problems, and then I'll work a couple of other problems just from the end of the chapter. The first problem says, to retire at a decent age and move to Hawaii, an engineer plans to trust her account to an investment firm that promises to make a real rate of return of 10% per year when the inflation rate is 5%. The account currently is valued at $580,000 and she wants to retire in 15 years. So this is the present value here, and is going to be 15 years. Determine how much in then current dollars. Remember, then current dollars include inflation. Constant worth dollars do not include inflation. How much in then current dollars will be in the account for the realized rate of return to be a real rate of 10%. So the real problem here is, what rate are we going to use? So let me go back and define things as per chapter 10, where we're really thinking about inflation. Remember, the market rate we give the symbol of I sub F, where, remember, F refers to inflation rate. And so that's the market rate. And the real rate, which is given to us in this problem as well as the inflation rate, the real rate is just I, and the inflation rate is F, little f. Now, since this account promises to earn a real rate of 10%, then what rate must it actually earn? Well, it must earn the market rate of I sub F, where I sub F, recall, is equal to I plus F plus the product, I times F. So in this case, what we're going to end up using is this rate, okay, which is going to be, remember, 10%, 0.10 for our I, and 5% for our F, 0.05, and then the product of those two will be 0.005. Okay, and so that will be equal to, as a decimal, 0.155 or 15.5%. So now it's just a matter of finding the future value at 15.55% of $580,000. So F is equal to P times find F given P at rate I for n periods, but this I is really going to be the I sub F, so I'll just put it there, I sub F. And so we're starting with $580,000, 580,000 times, and since this is a single payment factor, it's very easy. It's just 1 plus I to the n. So I'll just put it in as the algebraic form, 1.155, that's 1 plus I to the n, which is 15. And you can crank through that on a calculator easily enough, and you'll get $5,036,835. So that's the solution to this problem. That is in then current dollars. Now, that, if you think about today's dollars, 15 years from now, that's how many dollars you'll have, but they will not be as valuable as today's dollars due to that inflation. So if we wanted to know how much stuff could we buy in terms of today's dollars, we could convert this to constant worth dollars simply by multiplying it times 1.05 to the minus 15 power. So that would get us the constant worth. Remember, the function constant worth is equal to future dollars, or then current, which he called future dollars, F dollars times 1 plus F to the minus N. Basically, that gets you, if these dollars are at time N, which is time 15 for us, but this question is not asking for constant worth dollars. By the way, if it was asking for constant worth dollars, we would have just used the real rate 10% in here, and we wouldn't have had to reconvert it back. We would have known that that is the constant worth, or the buying power of the $5 million. It would be quite a bit less than $5 million in buying power. So the second problem, which is really part of the same problem, there were two problems that were connected, as you've had in other homework problems, but the second part of it was to write an Excel function to find this value of 5 million and so on. Well, recall in Excel, and I'm going the reason why I'm working this problem is two reasons. The first problem is trying to figure out which rate we use, the market rate or the real rate, and so on. So I'm trying to help you with that. And in the second case, I really haven't discussed a whole lot of Excel usage because I use the app almost all the time, but the author does ask you in this homework assignment problem to use Excel. So I'm going to do that one for you, basically. And so in this particular problem, what are we doing? We're finding the future value of a present principal sum. So we would start by saying equal, we would take any cell in our Excel spreadsheet and say equal FV, and then open parentheses. Once we do that, once we put that into a cell in Excel, it's going to propagate what you need to put in after the parentheses open. So what you'll see, once you do that, you'll see the following: equal, future value, and then you'll see rate and period, number of periods. This is the interest rate, and in Excel you can put the interest rate in as a decimal, or you can put it in as a percent. But if you put it in as a percent, you have to put the percent sign there. Okay, that tells Excel that this is a percent. And then this is the number of periods, and peer, and then PMT is basically Excel's way of saying an A series, a payment, a uniform series, an A series. And then you'll have another comma and PV here in brackets, and then the last one will be type, TYPE, in brackets, and then close parentheses. So once you put in equal FV, future value, open parentheses, it'll propagate this stuff, and then you have to fill that in. Okay, so then you would put in, you have this, and then what is your rate? Well, we found that the rate that we wanted to use was the market rate, which was 15.5%. So I'll just put it in 15.5, and I have to put the percent sign because I'm putting it in not as a decimal but as a percent. I could have put in 0.155 as a decimal, but it worked just as well. And then I put in the number of periods, which recall was 15. And then it's asking for the payment amount. Well, there is no uniform series. We just have a present value and a future value. So I'll put a 0 there. You could just put another parentheses and nothing there, but I prefer to just tell it that we have no payment, no uniform series. And then it's asking for the present value. And recall that Excel reverses the sign when it gives you an output. In that sense that it says you must invest $580,000 if you want to get this positive future value. If I put this in as 580,000, it'll give me a negative future value. But if I put it in as a minus 580,000, it will give me this as a positive future value. So I'm going to put in minus 580 and don't put any parentheses in there. 0, 0, 0, 1,000. And then the type, we always basically skip it. Put in a 0 there. Or just nothing, and I'm going to put in nothing. I'm just going to close my parentheses off right there. It'll assume end of period payment, which is a 0 for type. If you had, say, beginning of period payments, which we never have in this course, you'd put in a 1 for type. But in this course, you never put in the type or just put in a 0. You have your option. So this is what you would put in, and then Excel it'll return you the value of 5,036,000 that we got in the previous example. So that covers these two homework problems. I'm going to work some problems from the back of the chapter now, a couple of them. This is problem 18. 10.18 in the back of your chapter. It says, such a lucky girl. Helene was just told that she had inherited her great-grandfather's entire hedge fund investment account that contained $3 million. So that's a $3 million right now, okay? If he started the account 50 years ago. So this was a long time back when he started the account with a single deposit and never added even a single dollar to the account. How much did he deposit? How much did he deposit? So we're looking for a present value of this future value, which is really at the present time, but it's 50 years from the time he deposited it, of $3 million. And the number of years is 50, or the number of time periods. Now it says, assume the account increased at a rate of 10% per year, okay? So the rate that the account is going up is 10%. This is years, and that's per year. A lot of times I'll leave that off, but it's good idea to always put it there. And the inflation rate during that time period was 3%. Okay. So we want to know how much did he put in 50 years ago. So that's a present time relative to now, which is a future time relative to 50 years ago. And this account is earning 10%. Now, what kind of a rate is that, and what kind of a rate do we want to use? It didn't say whether this is a real rate or a market rate, but it did say that the account's earning 10%, period. So it doesn't matter what the inflation rate was. So this is irrelevant information, not needed. And in fact, I would call this rate here, I would call it a market rate, because that's what the account is actually earning. But we're going to work the problem then that the present worth that he actually deposited will be equal to the 3 million, that's the future value, times P given F at 10% for 50 years. And of course, again, since we're dealing with just a P and an F, this is going to be 3 million times 1.1 to the minus 50 power. Now, if you actually work that number on your calculator or using the app, either one, I got $25,556. The author used the tables in the back of the book, and this is so this is using the algebraic formula. If you had used the table and said present worth equals 3 million, which is what the answer key actually does use, P given F, 10% for 50 years, that formula or that value in the table is actually 0.0085, and so this turns out to be 25,500. There's a little bit of difference then, at $56. Since our answers only have to come within 2% of the right answer to get the right answer on the homework assignment problems, then either way you could work it, you're gonna get the right answer. 25,500 or 25,556. So the last problem that I'll work is problem number 19, and this problem says the makers of LifeStraw, a filter designed to allow the user to drink water safely from a stream, have a financial decision to make. Implementing an automated assembly process will cost $5,000 per year for the next 6 years. So basically we're looking at a uniform series, and that 5,000 is all then current dollars, because that's what it says, okay? The interest rate is 15%, and the inflation rate is 5%. Now, he did not state that this is the real interest rate or the market rate, and that's a problem. It should have said the real interest rate is 15%, okay? Because that's the way the problem is supposed to be solved, as though this is the real rate. And yet, when we have a uniform series that's given in then current dollars, we need to use the market rate to transfer dollars to get future worth or present worth. So the question is, so let's look at some of the things we have. We have A is a uniform series in then current dollars of $5,000 per year and is 6 years. And I, which is the real rate, is 0.15 or 15%, and F is 0.05 or 5%. And what is the amount they can spend now in lieu of these future costs? So what's the present worth of that A series? Well, in order to do that, we need to find, since that is in then current dollars, we need to find the market rate, I sub F. And again, recall I sub F is equal to I plus F plus I sub F. And in this case, we'll have 15%, 0.15, plus 5%, 0.05, plus the product of those two, which is 0.0075. And so when you do that, you're going to get 15 and 5 is 20.75% or 0.2075 or 20.75%. So then now it's just a matter of solving for the present worth. The present worth is equal to the uniform series P given A, I, N, and the A is $5,000 per year, and we're given P given A, and this is 20.75%, and N is 6. If we crank through that, we'll get $16,323. So what is the amount they can spend now in lieu of that? They can spend that much. Okay. Now, that's all part A. Part B is, how does this compare? Let's see. Where's part B? If only 12,000 is available now, so they don't have 16,000 now, they only have 12. What is the maximum equivalent amount they can spend for each year of the 6 years? So now he wants to take this 12,000 and convert it back to a uniform series. Okay, so we're just going to go in the opposite direction, starting with P. So for part B, we're given P equals 12,000, and maximum amount, what's A? Dollars per year, and we have N equals 6, and then I sub F is going to be 20.75%, and we crank through that. A is equal to P, find A given P at 20.75% for 6 years. And if you work that out, it turns out to be $3,676 per year. And then he asks an additional question: how does this compare with 5,000? Well, it's less than 5,000 by $1,324. So if we look at, do a little calculation over here to the side, 5,000 minus 3,676, we got 4, 2, 3, and 1. It's $1,324 less than 5,000. So you'd be coming up short if you only have 12,000 now. It's not enough. You needed 16,323. And that's it for this problem session. Thank you.